Okay. Let's start. Good afternoon, everybody. How are you doing today? Good. I hope that you are doing very well. Sorry, I was sick after class time, previous time, and I just recovered a little, but my voice cannot be kind of loud today. But I try my best. Please accept my apology. Please answer these two questions. Scan this barcode. Oh, please answer these two one. See class participation. Oh. Okay. Did you answer the questions? When is your time? Did you answer? I will give you one more minute and then I will show you the results. Okay. I want to show the results. Do you want me to show your names? Okay. First question, 86% answered correctly. Second question, 59% answered correctly. And let's answer the questions. We started to talk about dependent motion of particles in previous lecture. Dependent motion of the particle means that the particles, they are connected to each other. For example, such as a cable link, and the motion of one particle depends on the motion of another one. For example, for this one, if I pull block A and C downward, this block B goes upward, or the opposite of this one. It means that the motion of the B depends to the motion of A and C. This type of the motion is called dependent motion of force. And based on what are the base velocities, we can find the velocity of the other block or other particle or other body. Now, first question. That when particles are interconnected by a cable, the motion of the particles are, as I mentioned, they are always dependent. Why? They are interconnected by the cable. The correct answer for this one is B. For the next one, we want to determine the speed of block B when the block A moves down with this speed, and block C also is moving down with the speed of 80 foot per second. Now, let me bring this one here. For example, this simple system of the pulleys and also blocks is given to you. You want to relate their velocity and their position. First, you need to select the datum line. For most of this type of systems, just put the datum line at the top point, passing through the top pulleys, for example. Then select the coordinate system you want to just from this direction. The datum line will be positive. I consider downward as a positive direction. And then we need to find the position of the blocks or the particles based on the datum line. For example, this is only one chord. To relate the position of the A, B, and C, we need to write the position equation. How we can write the position equation? If I find the total length of the chord, LT is total length of the chord. Now for the total length of the chord, if this length shows the SA or the position of the A, and also from this datum line, this part shows SC and also these two one. They are SB. The total length of the chord I can write based on the position of A, B, and C. And I neglect the chord around the pulleys. The total length of the chord, it will be SA plus 2 times of the SB plus SC. This is position equation, first step. If just call this one equation 1, now I want to find the velocity equation. To find the velocity equation, if I take the derivative of position equation, bless you, derivative of this one with respect to time, it will be the derivative of LT with respect to time equal to derivative of SA with respect to time plus derivative of 2SB with respect to time plus derivative of SC with respect to time. Now, from this one, how much is this one? How much is the derivative of LT with respect to time? 0. Why? Yes. constant. Consider that this link is in extensible chord or cable. The derivative of the length of the chord will not change during the time. This will be 0. What is this expression is called? What is this expression is called? VA. I heard somebody. It's correct. It's called VA. It's the velocity of the block A. Similar to this one. This is 2 times of the velocity of the B plus velocity of the C. Now, we need to substitute those values into this equation. Velocity of the A, it is 6 plus, we are looking for the velocity of the B, and velocity of the C, it is 18, equal to 0. Now, from this, we can find 24 plus 2 times of the velocity of the B equals 0. From this, velocity of the B equal to minus 12 foot per second. If you just see here, this sign, negative sign, it is consistent with the motion of the block B. Why? Pull this one down, this block B goes upward. Because I select this direction as a positive direction, going upward shows it here. If you do not find negative number, something wrong with your calculation. Or you selected the differences or selected the coordinate system and you are wrong. And the velocity of the V, the magnitude is 12 going upward. For the second one, C is the correct answer. I just moved back here. Any questions? For example, for the homework I gave to you, last question, there are 2 chords, okay? When you just find, I explained the tips. Instead of 1 equation, you have 2 equations. And then, in between these 2 equations, some chord is common, some lengths. You have to just eliminate. You have 2 equations, you can relate it to each other. And find 1 velocity equation, then similar to this. Any questions? Also, I put some practical examples for you, similar to those practical examples. Those are very good examples. Just follow them. You can answer the last question for the homework. Okay? Any questions? Yo? Can I move to the next slide? Okay. Now, I want to talk about the independent motion. You learn about the dependent motion. The motion of one depends on the motion of another one. How about that 2 particles, they move independent, such as 2 cars, such as 2 boats. They just move independent. How we can relate their acceleration, how we can relate their velocity, how we can relate their position. Today, I'm going to relate absolute and relative position equations. And I applied the velocity and acceleration relations. And we can interpret the motion from different reference frames. You will see on the next slides. For example, it's a very simple example. There are 2 cars, car A and car B. Okay? Car A moves with the velocity or speed of the VA in this direction. Car B moves with the velocity or speed of the VB in this direction. Now, they move independently. Their motion are independent of each other. Such as your car and another car in the highway. They are independent motions. They are not dependent to each other. Yes, if you just attach a kind of truck to the trailer, their motion are dependent to each other. However, these are two different and independent particles or independent bodies. Now, look, there's a police car just hiding somewhere and tracking the positions. Okay? The person, the officer in this car, can see your vehicle's speed or the other vehicle's speed independent. Got it? However, this passenger in this car wants to see what is the relative velocity or velocity of the B with respect to A. This passenger cannot see this one. It can see the difference of these velocities. Or if they are just moving with the same speed, this passenger sees that their relative velocity is zero. Same speed, same directions. Just look like that. It's not moving that car. Okay? However, if this one starting to increase speed, pass through this one can see the differences from this view of this person. Now, from this example, I want to show the vector representations. For example, guys, this is a lake, this place. Okay? This is a lake, and at this point, there is a one observer at the beach. There is one boat at B position, one another one at A. They are moving on the same lakes. This person, if I attach a coordinate system called XY, it's a fixed coordinate system. This person just sitting, and this coordinate is attached to this person. This person doesn't move. However, I attach another coordinate system to the boat B that's moving in the lake. Now, this person, based on the view of this person, it can see the position of the A and the B using RA and RB using this coordinate, the capital coordinate system. RA and RB, they are absolute positions, same as the police car watching your speed and watching your positions. However, based on a person sitting on the boat, there is a relative position called RA with respect to B. This is called relative position vector of the A major to the frame of the AB or XY. Now, sometimes it can see this boat become far away from this one or becomes close. Depends to these positions. Now, how we can relate their positions and RA with RB and RA with respect to B? If I use the summation of the vectors, summation of the vectors to relate, if I just add the RB plus RA with respect to B, RA is the resultant one. Or I can write RA in the vector form equal to RB plus RA with respect to B. This one is called a position vector. or relative position vector in vector form. Okay, in the vector form, you can see that. I just write in the bold character. These are vectors, not a scalar. This is a vector, this is a vector, also this one is a vector. Now, we have the relative position vector. Now, what I want to do in the next slide, I want to find the velocity vector. How I can relate their velocities. For example, this boat has a velocity of 60 miles per hour. This boat has a velocity or speed of 100 miles per hour. How I can relate their velocities? To relate their velocity, if I take the derivative of this equation with respect to time, derivative of position will be velocity. Now, if I take the derivative of velocity, the position vector, just from previous one, RA equal to RB plus RA with respect to B, this is a position vector. Now, if I differentiate with respect to time, the derivative of the RA with respect to time will be VA. The derivative of the RB with respect to time will be VB. And the derivative of the RA with respect to B with respect to time is a VA with respect to B. Or VA is the absolute velocity of the A. VB is the absolute velocity of the B, particle B, and VA with respect to B is the relative velocity. The relative velocity of the A with respect to B. Similar what I did for this equation, if I take the derivative of this equation with respect to time, also I can find the relative acceleration vectors. If you take the derivative of this one with respect to time, also you can find the relative acceleration vectors. Now, for example, return back to the previous example I just showed you. If car A has a velocity or speed of 100 miles per hour and car B has a velocity or speed of 60 miles per hour. I just made a kind of very simple example. Now, I want to find the relative velocity or relative velocity of the A with respect to B. If I use this equation, VA equal to VB plus VA with respect to B. Now, in terms of the vector form, I know that these are moving on the same directions. However, for more complex ones, if their velocity will have some angles, or just this car, so next example, just moving along a kind of another curved path. If you use this one, just use and write the VA, VB, and VA with respect to B in terms of the vector form. For example, if this is the I vector and J, these are the unit vectors along X and Y, I can write the VA as a magnitude 100 in the I direction equal, look, I just write them as a vector form. VB is 60 in the I direction plus this one that we are looking for. Now, from this I can find the velocity of the A with respect to B, it is 100I minus 60I, or it is 40I. What does it mean? The velocity of the A with respect to B as a passenger sitting on this one, it is 40 miles more than the velocity of the B. Very basic example. This can be goes to the, for example, system of gears, goes to the mechanisms, and very complex ones. But you can see from this example, or the velocity of the B with respect to it is minus of this one. Why minus? B is minus 40 miles less than the speed of this one. Or from the view of the passenger sitting in this car, our car, for example, is 40 miles speed is less than this car. Yeah. Can I move to the next slide? One more thing I want to mention. First, how we can draw RA with respect to B. For example, there are 2 points, 2 particles, such as A and B. If I want to draw the relative or RA with respect to B, which vector do you think that is the correct one? The red one or the blue one? Yes, I collect your answers. Yes, the blue one. It's 1% blue. Other students, yes. I want to mention that if we want to draw RA with respect to B, which vector do you select is the correct one? The blue one or the red one? If you saw the Matrix movie, select the kind of pill, the blue or red. Which one do you select? Yes. Blue. Other students? Yes. Blue. What do you think? You. Blue. Blue. Is there any person mentioned red is the correct one? All agree blue is correct? Yes? Blue. Blue is the correct one. I give you a tip how to just select this one. Why? Later I need this one. In the relative velocity of the rigid bodies, I will show you why this one is important. First, why? As you mentioned, the correct one is the blue. What is the red one? It's the RB with respect to A. These are all in their magnitude, but they are opposite in their directions. Okay, one reason. Then, how we select which one is correct one, or is B toward to the A or A toward to the B? I memorized this tip when I was an undergrad. I want to share with you. Look, if we look at this one, A and B, look like this. RAB, just look like this. Consider B is a person with lower rank in a company. People with lower rank or lower salary wants to get higher one. Always I remember this trick. B wants to go to the A position. All of you in your company, when you just recurred, you want to be a manager. You do not want to downgrade your position as a, for example, factory worker or something. You want to be a manager. You want to be a supervisor. You want to be a vice president, for example. Means that B wants to go to the A position. I remember all of this things. All times, B wants to go to the A position. Or you will see that here, for this blue one, B goes to the A position. Or for this one, A wants to go to the B position. That's it. It's a trick. Okay. I memorized those ones from when I was an undergrad student. Then 20 years ago. Okay. Now, you learn about this ones. And similar to this, velocity of the A with respect to B equal to minus velocity of the B with respect to A. And the acceleration of the A with respect to B equal to minus acceleration of minus acceleration of the B with respect to A. Consider this one. Why? Again, from using this equation, I will provide those equations in the exam. You do not need to remember. For this one, if you select an opposite one, instead of adding a number to the RB, you subtract. This is one reason. Instead of RA with respect to B, if you select RB with respect to A, it's a negative one. Instead of adding a number to the vector, you subtract a vector. It makes a kind of difference in solution, and you will see you will lose lots of grade. Any questions? No questions. Okay. Now, this slide, just I put it for all of you. I captured from book. This is for your reference. You want to study for exam, for the questions, for the homework. These are the equations. These are the summary about the RA, what is RB moving in this direction, what is the independent motion. and how you can relate for your reference. That's it. Let's solve example. I select this one because all of us driving, we change kind of directions. We see that, for example, you're driving I-75, several cars just added to your I-75 from Jackson, from Auburn Hills, from different areas. For example, at the instance shown here, car A, it has a velocity or a speed of 20 kilometers per hour, which will increase at the rate of 300 kilometers per hour square. As the car enters the expressway, at the same instant, car B is decreasing at 250 kilometers per hour square. We're traveling with a speed of 100 kilometers per hour. We want to find relative velocity of the A with respect to B and relative acceleration of the A with respect to B. One example exactly replicate to your life using car and adding other ones. Give you 1 or 2 minutes just if you want to write it. If you want to think about this problem, just think I will start solving this question. Okay, let's solve this problem. Both cars, as selecting both cars as a kind of particles, for example, they have an independent motion. Car A has a speed of 20 kilometers per hour. These are given for this problem. It is 20, the speed is 20 kilometers per hour, which being increased at the rate of 300 kilometers per hour square. Now, what is this means? What does this mean? The increase at a rate of 300 kilometers per hour square. What is this? Yes. Acceleration. This one directly doesn't mention this one is an acceleration, but the acceleration of car A in this direction, it is given 300 kilometer per hour square. And the car enters the expressway, and the car B is decelerating. Decelerating means that the acceleration of the B, the magnitude for these are scalars. AB is decelerating. Look, decelerating means that it is minus 250 kilometer per hour square. And the speed of this car, it is 100 kilometer per hour. What I'm looking for, I am looking for to find exactly what mentioned, the velocity of the A with respect to B, and the acceleration of the A with respect to B. I am looking for this two one. To find this one, the solution. I will use the relative motion. What does it mean? I divide this problem into two parts. First, I will solve the relative velocity. For the second part, I will find the relative acceleration. For the first part, to find the velocity of the A with respect to B, I will use this equation. Velocity of the A equal to velocity of the B plus velocity of the A with respect to B. This is the relative velocity equation. Now, what I have in here, look, the velocity of A, we are looking for the vector forms. Just this one, it's moving in this direction. If at this point, if I select the coordinate system, XY coordinate system look like this. And the unit vectors along them are I and J. I want to write the velocity of the A in terms of the vector form. Can you say what is the velocity of the A in the vector form? Any persons? Yes. What is
20J, negative 20J.
correct? Negative 20J. The velocity is downward based on this coordinate system. This is a conventional coordinate. Okay, just using x to the right is positive, upward, y is positive. Based on this one going downward, at this position the velocity is downward, it is minus 20J. From this equation, left hand side it is minus 20J. What is the velocity of the B in the vector form? What is the velocity of the B in the vector form? Who was the first? You answer the first one. You answer the second. Plus 100. Correct. The velocity of the B is going upward in this direction. Magnitude is given. The direction in the J is 100J. Plus velocity of the A with respect to B. Velocity of the A with respect to B, it will be minus 20J minus 100J. It is minus 120J. velocity of the A with respect to the magnitude is 120, it is downward. I can make this problem different. Why? Instead of this position, I can put the car A in here. If car A is in here, the velocity will be in here. Means that the velocity has component along x and y. I can change this one. Look, I can play with the equations and problems for the exams. Instead of putting here, I can put it here. Instead of put, I can put it here. Easy. Now, we found the kind of the relative velocity. The next one I am looking for to find the relative acceleration. Any questions? Can I go to next slide? Yes. Now to find their acceleration or relative acceleration, I will use this equation. Acceleration of the A equal to acceleration of the B plus acceleration of the A. With respect to B, we are looking for to find this one. To find this one, I need the acceleration of the A and acceleration of the B. But let's go to the simple one. The acceleration of the B, if you just refer to here, the acceleration of the B, it is minus 250. Okay? Means that this one, if I use another color, it is minus 250. It is in the J direction. Plus, I am looking for the acceleration of the A with respect to B. From previous one, it mentioned that the acceleration of the A, it is 300 kilometer per hour square. What is the acceleration of the A? Yes. Negative 300J. I collect the answers. Acceleration of the A, you mentioned is minus 300J. Other students, do you agree? Or you want to change this one? Is this the only acceleration? Yes. Yes. Other students, is there any person who opposing this one or wants to adding something? Yes. Would be a your close. That's what I'm looking for. Not intention. You're close. Normal. Yes. Yes. I'm looking for that. At this one, this is not the only acceleration. There is one more acceleration. It's hidden. Also, you will see that why I gave this 100 meter. Every numbers matter. There is one more acceleration in this direction. Okay, and what is this one? If you remember, when a kind of particle moves on a curved path, there's one acceleration in tangential, one acceleration along normal. This acceleration is given 300 kilometer per hour square. This acceleration can be found is equal to v squared divided by rho. Do you remember? Now, the acceleration of the A, just delete this one.
Acceleration of the A has two parts. One, this one, it is negative minus 300 j, and one in this direction, that is v squared divided by rho. That is in minus x direction. It is minus the velocity or speed of the car at this position. It is 20. Okay, minus 20 square divided by rho. Rho is in 100 meter, or it is 0.1 kilometer divided by 0.1. This one, what is this? This is the v square divided by rho. And it is in the minus I direction. This is the point of this problem. Also, if you are curious, if you are solving this one, maybe this question comes to your mind that what is the difference if the car is moving in this or there's a one straight lines? If I just put this only directions, what is the difference if I just moving along a curve? How is the difference between those ones? Okay, this is the reason. Just be careful about the curve ones, even for the velocities, even for the accelerations. Now, if I put the acceleration in A in here, it is minus 300 j, and this one, it is 4,000. Minus 4,000 j, sorry, minus 4,000 I. Now, we can find the acceleration of the A with respect to B. How? I bring this one to the left. Means that minus 300j plus 250j minus 4,000i, or just change the order. This one is minus 4,000i, and this also will be minus 50j. This is the acceleration of the A with respect to B is minus 4,000i minus 50j. The magnitude of this acceleration, it is square root of the 4,000 square plus 50 square. If you calculate this one, let me cheat from the solutions. It is 4,000 kilometer per hour square. And also, we want to find the direction of this one. Look, if we draw this acceleration in the xy coordinate system, if this is x, this is y, because these two one are negative, this is the acceleration of the A with respect to B. This one is minus 4,000. This one, it is minus 50. Now, if we find this angle, also we can show the direction. To find this angle, tangent theta equal to this length, 50 divided by 4,000. This theta can be find tangent inverse of the 50 divided by 4,000. The angle will be 0.716 degree. For the next homework, I will give you similar example, but a little bit just complex.
How? Instead of putting here, because I will put this car here. Is that the velocity has two components. That's it. What similar procedure? Any questions? Any questions? No? 5 minutes break. Okay. Sure. Okay. Let's resume the second part of the class. Any question from first part? Any questions?
Okay. Now,
I talk about the kinematics of the particle, about the different motions in different coordinate systems, dependent motion analysis, independent motion analysis of the particles. Now, I want to know that for a particle that moving along different levels or different motions, how we can find the forces applied to the particle or the body? How can I relate the forces with the kinematics equations that we found in the previous chapter? Also, you know how to draw free body diagram. This is from the Mech 210 course. I do not teach how to draw, but I will read you. And what I need to add, I will add how to draw the kinetic diagrams. Maybe you already, most of you know about the equation of the motion or Newton's second law from physics or other courses. But here in dynamics, I want to develop the vector form into scalar forms and show you different aspects of the Newton's second law. And I want to show how to relate the kinetic diagrams with the equation of the motion. And we will review the Newton's law of the motion. And I will review also the free body diagram, how to draw, and also solve several basic examples to just review how to draw. And also, hopefully we have time. We will have the class homework at the end of today's class. Then I will give you one problem to draw free body diagram for you. Okay, just this one. Consider this one. Pay attention, please. Already just printed. Now, why I need to just learn about the equation of the motion. Why I need to just find the forces in the particles, forces in the rigid bodies. Why we need several applications you will see here, such as this mechanisms. For example, this mechanism that working robots in different machinery, simple to this one, adding a motor with a different angular velocity and angular acceleration. You want to know that how much force is needed to move this peg point P. This P is connected to another part that just move it. For example, in the company, just move one part, just stamping or something like this. You do not know the mechanism under that kind of that's one. But you will see, and you can design this one. And you want to know that how much force is needed to move this one along this slot. Or how you can relate this angular velocity with the forces that apply to this peg point P. Or for a car, That's how much forces is applied to the tires if just move on the bump or just moving in a different velocity or different road conditions. As a mechanical engineer, you want to design those suspension systems, or you want to see how much is the deformation of the tire, okay, under different conditions. For example, this question might be comes to your mind that is this suspension is just same for every conditions? No. For example, if the car moves with 80, for example, mile per hour, about 60 miles per hour, just if this one wants to move around a kind of a curved path, does this one affect the forces applied to the suspension system? How about the forces applied to the tires? How about the weight of the passenger? How about this one when this moves, there's a tilt angle or other factors? Or here, roller coaster. Have you ever tried for a roller coaster? Who tries? I did. I scared. My wife pushed me to just go for a roller coaster. I never. I scared. But one thing, have you ever, any of you, I just watched from windows, not close. Have you ever saw the mechanisms that control the speed of this roller coasters? Try it. Just you can watch in the YouTube. There's a cable or just a kind of attached to this one that just push and just make a break and those things. If you're curious, you can watch those mechanisms that just design those ones. Okay, I just watched it several years ago. You will see that those chains, okay, they change the velocity break. When you go up, just suddenly it hold that roller coaster and then suddenly release you. There are those type of mechanisms. If you are interested, just those ones. And also, this is the close-up of those ones. How those brakes work, how they move this roller coaster with different passengers. Just try to watch. It can change your mind. Okay, now, also, you want to design this elevator with different rates, and also you want to design how many brakes is needed, or to just move this elevator, just for example, how long does it take to move this elevator from several floors to first floor, or how long does it take to move from one velocity to another one, and depends to this weight. Does this weight affect this time that stop? Does this one affect the forces that just moving and kind of elevator, or there is some motor you want to design to just see the torque, how much is needed? To relate those forces, you already found those forces for static one in the Mech 210 course. Just for example, if I gave you this one at this moment and ask you to draw a free body diagram, you can draw those. However, during the time, we want to just relate the forces applied to this elevator with the velocity or the acceleration or the time that it is needed to just stop, or how we can relate these forces with the time is needed to stop. For example, if you want to just stop the elevator for 5 seconds. Okay,
Now, these are several applications. Just a quick review. The equation of the motion, we already know about the equation of the motion from physics. All of you, I can promise, you know equation of the motion. But this is an equation of the motion. Sigma F equal to ma. In different references or notations might be just use F equal to ma. Okay? Just instead. But here, I just added this summation because this F is the summation of the forces, or is equal to resultant forces. Now, to use the equation of the motion, first we need to draw free body diagram. You learn about the free body diagram. Just if this is a body part particle, and these are the external forces applied to this particle, we will show all external forces on free body diagram. Okay? Now, question. Why not internal forces? Why we do not show the internal forces on free body diagram? Why? This must stop. Here's the same problem. Maybe it becomes hard to just stop. Sorry, but this is technology issue. It comes. My question, why we do not show the internal forces on free body diagram? Why? Why? Fundamental question. Yes? Yes. Internal forces cancel out each other. They are action and reaction forces. Okay? They are action and reaction forces. If I just divide the summation of the force into two parts, look, the left-hand side, it is including summation of the force of internal plus summation of the force of external forces. This term is zero. They cancel out each other. They are in opposite directions. This is the reason we just show all external forces. If you want to go and continue your studies for the PhD, okay, to be a PhD candidate, there's a comprehensive exam. The comprehensive exam, it has two parts. One, oral, one kind of just read and want to solve equations. For the oral one, 3 to 5 to 7 professors sit. You just stand here. They ask you this fundamental question related to your field. For example, you know about the stress, for example. This is not from my course. But can you introduce the stress? They want to know how much you learn about the courses, how much you learn about the fundamental of mechanics. And these are some of the kind of very kind of small questions. Why, for example, small external forces, not internal? You have to know those ones. You have to curious your minds. Why,
for example, not internal forces. Now, the second one, to use the equation of the motion, we will draw a kinetic diagram. This part is different from physics. We will show the kinetic diagram. What is the kinetic diagram? We will show the inertial forces. What are the inertial forces? It's MA. It's the inertial force. We will show the inertial force only to use, and also this one is called kinetic diagrams.
Now, if you just look at this one and refer to the equation of the motion, summation of the forces, we can find the forces from the free body diagram. And also, from kinetic diagram, we can show the MA, or inertial forces. Might be it's easy for a particle or body just moving in a straight line. However, for a body move along a curved path, okay, or complex motions. This kinetic diagram, you already learned in the statics, this part is 0. This is the reason you didn't draw any kinetic diagrams. Okay? You learned how to draw free body diagram in statics. But in this course, this helps you to show inertial forces and what's the direction of this one, and relate inertial force with the sigma F, or resultant force. To apply the equation of the motion, there are several steps. First, we choose a coordinate system. What type of coordinate you want to select? You already know about the XY coordinate system. Also, you learn about the normal tangential coordinate, or NT. Also, you learn about the polar coordinate, R and theta. You learn this one, might be in physics, to select this one, but we extend this coordinate system for normal tangential and polar coordinate system to show the motion in different coordinates. The next step, we draw the free body diagram. We show the all external forces. And we break the forces into components. Why? Because we want to know what are the forces along X and the Y direction. For example, I will show you later in the next example. If there's a P applied to this box, we can find the component of this force along X and the Y. These are P cosine theta and P sine theta. Why? We need to break the forces because we want to know what are the forces along the X, what are the forces along the Y directions. The next step, draw the kinetic diagram. To show the kinetic diagram, for example, this box is moving with an acceleration of the A. To show the kinetic diagram, we just draw this vector, that this vector is ma, mass multiplied by acceleration. The next step. Finally, we will find and use the equation of the motion. You learn about the equation of the motion in the vector form. How about the equation of the motion in a scalar form in different coordinate systems? Remaining of this lecture and also future lectures, I will develop this ones for XY, normal and tangential, and polar coordinate system. And finally, for example, if you're looking for the time, or if you're looking to find the velocity, for example, for that example of the elevator, you want to know that how much does it take that this elevator comes to it has a kind of a velocity of 0. If I just increase the brakes forces, does it affect the time? Yes. You will see they're relative. And does it affect the final velocity? Or, for example, how about if I increase the acceleration of the motor? If I just select a kind of a strong one, does it affect the velocity of this one? Yes, it will affect. How can I find the just torque of the motor affect this one? This one affects the acceleration. Then from the acceleration, you can find the velocity and time. This is how you can relate them together. Any questions? No questions? Okay. Now, I just caught and also just copy paste from the book. This is, I think, a Merriam. These are the how we can draw the free body diagram. For example, for different conditions, for times, for the tensions, forces on smooth, or if it's a rough surface, or if you have a roller support, or freely sliding one. Just please review all of them. Okay? This one is an important one in my lecture. If you cannot draw the free body diagram, you cannot solve the problem completely. Okay? Is that you have to know how to draw a free body diagram. Then, this slide is from my colleague. Just I copied from my colleague. This is called recipe of free body diagram. How we can draw. We choose what you want to draw. For example, the body, for example, the kind of the wheel or this box or anything. First, isolate the body. Separate anything just touching or attaching. Show the coordinate system. And identify all external forces. It's a weight, normal force, frictional force, strain force, applied force, contact force, just magnetic force. Might be applied to that one. And finally, show any relevant dimensions of the find the moments. Might be applied moments. We will use these moments later in study of the rigid body. Let's solve examples. Just a basic one. How to draw a free body diagram. These are very basic. Draw a free body diagram of the blocks. There are 2 blocks attaching using a cable. The coefficient of the friction is mu k. The mass of each block is m. We neglect the mass of the pulley and the cord. I want to draw a free body diagram for this 2-1. First of all, look, I select XY coordinate system. It's a coordinate system. Now, I selected body A or particle B, or particle A and particle B, and I isolate them. Means that I just deattach or deassemble all of the parts, just attach to them. But I will show their effect. This is the body B. One force, it is the normal force. There's another one, it's the weight. It is equal to mg. If consider this one is going downward, this one going this direction, there is a frictional force in this direction. Now, can somebody tell me how can I find the frictional force? What type of equation I can use to find the frictional force? Mu Ku multiply by, what is the equation can be used for the frictional force? What? Yes. Mu k multiply weight, mass. Yes. Multiply by velocity. Frictional force is equal by frictional force is equal by mu k by multiply by, yes, normal force. Normal force. Not the weight. Also, the effect of the tension cable. This is a tension applied from the cable. Look, this force caused this one to move to the left. Also, for the body A, there is an action and reaction, just tension. There is a weight equal to mg. Also, I just consider there is a gap in here. There is no attached to the kind of this one. Just to consider normal force and the frictional force in this direction. Got it? One example. From this one, you learn and also review this is this. The normal force, it is perpendicular to the surface. Weight, it is always vertical. Look, weight force, it is always vertical. For example, look, if there is this box is moving from the slope, okay? This is a very common mistake I have seen from my previous one. Just they put the weight exactly in this direction. Do not put the weight, just for any conditions. Just draw a line in your page. Just draw the weight exactly parallel to this vertical. It doesn't depend that this one moving in the slope or on the kind of surface, kind of smooth surface or anything. This is the correct weight, first of all. Then, go to the next one. For this one, there's an applied force of the P. And we do not neglect the force. For this one, just there's a normal force, there is a weight, and because this one's moving this direction, there's a frictional force. It's called mu k multiply n. But the point for this one, look, just draw the component of the force along x and the y direction. Y. We need these forces later. Why? Because we want to know what are the forces applied in the x direction, what are the forces are in the y direction. Just write the forces and find their component if they are not aligned x or the y directions. This is another one. Can I go to the next slide? Yes. Now this example. There is a 25 kilogram block. It's subjected to the force of 100 newtons.
and the spring stiffness is 200 Newton per second. If the block is moving from the position A to the position B, moves less with the amount of 0.4 meter, and this spring will be extended. I want to draw free body diagram and also kinetic diagrams for this example. I will give you 2 minutes to draw the forces that apply to this block. Find the forces. For your reference, the force of a spring, it is K, the stiffness, multiply S. S is deformation. Might be you use different notations in different books or references. Some use delta X, some use delta S. It just depends on the references and notation. Do not confuse or use S in here. But we are in the same page. S is deformation. Even you use delta X or even you use delta S. S is the deformation of the spring. Okay, let's do. I will divide my page into 2 parts. One part I will draw free body diagram. One part I will draw the kinetic diagram. Why? This is related with this equation. If you know the equation of the motion, sigma F equal to ma. Okay? Left hand side related to free body diagram, right hand side related to the kinetic diagram. Now to draw free body diagram. This is a block. Just there's one force called it's 100 Newton. What else applies to this one? Yes. Great. What's the direction? Down. Then weight, it is 25 multiply 9.81. What else? Yes. Force of the friction. What's the direction? Opposite direction. But we do not have the friction. Yes. Normal force. Nobody goes to the other force. Other. What else? Yes.
The force that the spring's putting on it and its X and Y components.
Okay. Did you find those ones?
Yeah.
How much are they?
I got 80 sine of theta, and then I did 80 cosine of theta.
Okay. Means that you find this force Fs as 80, right?
Yeah.
Okay. Let's see this one. Fs, the force of this, the K stiffness is 200, and S is the deformation.
we know that the initial length of this spring, it is 0.3. You just mentioned is on a stretch. Then go here. This is the final length of this one. And to find this one, we have this distance, 0.4. Just mention you just move 0.4 meter. We can find the final length of the spring. The final length of the spring will be 0.3 square plus 0.4 square. It is 0.5. Means that the total length of the spring will be the difference between the initial one minus the final one minus initial one. Means that L minus L0, this will be 200 multiplied by 0.5 minus 0.3. This will be 200 multiplied by 0.2. This will be 40. And also, this one has an angle. To find this angle, because we want to find the forces along the x and the y, this one just tangent theta equal to this length divided by this length, 0.3 divided by 0.4. Theta is tangent inverse of 0.3 divided by 0.4. If you find this angle, just used tangent arctangent. Okay. Tangent inverse of 0.5. Where's the arctangent? We have it. Just want to change. No, I don't have. Can you calculate it? My calculator doesn't have it. The arctangent. Calculate the theta. Does anybody calculate it? Or I can use the online. Yeah. 0.75. Is it correct? Yes. It's 36 degrees. Now, the angle will be 36 degrees, and we can find the, we can find the component of the force along x. It will be Fs cosine 36 degrees, and also along the y, it is Fs sine 36 degrees. The last part is the kinetic diagram. Easy one. Just draw this one, and the kinetic diagram you should show ma, or mass multiply acceleration. Mass we have 25. That's it. 25 multiply a is the kinetic diagram for this. Can I move to the next slide? Any question, guys? What you have to do, please, just find your notes in static, or just return back to the static books. Just review how you can draw free body diagram. We need it for this lecture and this course. Next, as I mentioned, This is an equation of the motion in the vector form. But I want to develop this equation of the motion and expand this one for different coordinate system, xy coordinate system, normal, tangential, and also polar coordinate system. Using these three coordinate systems, we want to just expand the kind of equation of the motion. Why we need, sometimes according to the problem we need to solve, as you can see for this type of examples, the forces are along the x or along the x or the y directions. We can relate the forces along the x with the acceleration along the x or acceleration along the y directions. Now, these are some applications, as I mentioned. For example, we want to find out how much is the kind of the horizontal force at this coupler. If you want to just throw a kind of bolt using your truck, okay? Or, for example, if you want to find how much the distance that the package will slide on this roller, or find the velocity of the elevator. The elevator goes up and down. We want to relate the forces that they are along the y direction with the velocity of the elevator. Okay? These are several applications. To find them, you know about the rectangular coordinate system or Cartesian coordinate system. Cartesian coordinate system in a 2D is the xy, or for a 3D one, it's the x, y, and z directions. Now, already all you know about this equation of the motion, force equal to mass multiply A, and also just make this one in the blue color. That unbalanced forces cause the acceleration. If there are balanced forces, there is no motion. The body stays or rests at that condition or moves with a constant velocity. If there is no, if there are no unbalanced forces. Also, if I just stand and also find the component of the sigma f, or resultant force along x, y, and z, and also find the component of this vector A along x, y, and z directions. Just very simple example. Do you remember that box I mentioned to you? There is an applied force of the P. It has an angle of 30 degrees. I found the component of the force along x and the y. I can write this P vector as a vector form, as this one is P cosine 30I plus P sine 30J. Okay? This one, it's a summation of the forces along x or forces along the x. These are the forces along the y, or only force. Just consider there is only this force. There's no normal force weight. Just it's isolated. If I extend this idea and generalize it for the 3D one, okay, just I add this one. The 3 is along the z. And simultaneously, the acceleration along x and the y and z. For this one, for this box that is moving, it will move in along this direction only. Okay? If you just pull a box on the ground, just it moves along this direction. The acceleration for this example has only one component. How about this one just moving as a projectile motion? Or a particle just moving on a space, such as launch vehicles, such as missiles, such as other airplanes. The acceleration has three components.
Now, if I equal the left-hand side to the right-hand side, I equal the I components equal to J components and equal to Z components. And finally, I can conclude that sigma fx equal max, sigma fy equal may, and sigma fz equal to maz. What are they? These are the scalar equation of the motions, not vector form of the equation of the motions. You just easily can, instead of writing them as a vector form, just you can write them as a magnitude. Just here, instead of sigma fx as a vector form, you can write only p cosine 30. Instead of this one as a p sine 30, just you can write it here. And there is no forces along the z. This is how we expand the equation of the motion from vector form to the scalar form. Any questions? No. I want to stop. Okay, but I will explain those one in the next session. But I want to review based on next Monday, we will have quiz. Okay? Please study just the free body diagram and also those one are just I brought after the exam one. Okay? This is a reminder. Also, for your homework, please submit them until tonight. Okay? Make sure you upload them before 11:59. I have some students still, after 10 semesters, just upload 11:58 point something. Please upload it. Please. And then send me, and do not send me an email. Professor, I want to just send it at 11:58. The system crashed. There are kind of, the fluent area, there is a kind of crime, just, I cannot submit it. Please submit at 11 p.m. Something will happen. Okay, this is for quiz. Any questions? No. But for today, I will distribute this way. It's a class participation. Just draw free body diagram for this kind of figure. Write this one, scan it, upload it in the Blackboard. I just write the instructions. Make sure you upload in the Blackboard, and then you can leave. Write your names, upload it, draw a free body diagram, and that's it. This is class participation. Do not worry about the. Great. Do not stress. It's not good for your health. Please draw the free body diagram for both blocks separately. I just mentioned. And upload in the Blackboard. I just make this one available. Here, you can see in the week 5, uploaded in class homework 1.
I grew mine out. I grew mine out like a few years. That was not
That's just how I want to do it. Just use the weight, not use mass. Yeah, no, sure, sure. That's great, just one use for that one more. The force of the root. Yes. It is my math. You forgot the source of the. Yeah, okay. Hey guys,
So the these squats should not be with it.
yeah, it was really. Yeah. For tomorrow, yeah. You got 24 hours. It's I'm just gonna work on it. Just like yeah. For example, wait, slow. The reason that this one's coming down, there's no friction. Because there are the force of the wind the force of the end this causes this to slide down. Yeah, the first one. Yes. But the first time I saw this when he first came in, I saw the thing out there, right? I was like, I don't know what that looks like. Class hasn't started yet, so I'm so they would be that. Yeah, sorry. I know. Gravity always. What's it doing about the house?
And that is important.
Yeah.
So that's just 998 times. And actually solve.
Yeah, the labor of mineralization complex. Yeah. That's only. I thought there were three.
Have a great weekend.
You too, thank you. You too.